أعزائي طلبة وطلبات شهادة الثانوية العامة قسم رياضيات لغات، أهلا بكم. النهاردة إن شاء الله هناخد درس جديد في الجبر اسمه المصروفات. Welcome my dear student in our math program for secondary 3. Today we are taking new lesson in algebra. It's titled matrices. What do you mean of the matrices? We studied the previous matrices of 2 columns or 2 squares. Today we are taking matrix of 3 row and 3 columns. Dear student, from our previous study we know that the matrices A, B, C, X, Y, Z is matrices 2 rows and 3 columns. So its order is 2 times 3. But the matrix LMN has one row and 3 columns. Is matrix of 1 row and 3 columns, so that its order 1 times 3. And the matrix A, B, C, D is called square matrix. Why? Because has 2 rows and 2 columns. 2 times 2, its order of this matrix. Look at the matrix A, B, C, X, Y, Z, I, M, N is square also. Why? Because it has 3 row and 3 columns. Its order 3 times 3. The matrix 0, 0, 0, 0 square matrix, all elements are 0, is called 0 matrix or identity matrix in addition. Its order 2 times 2, and the matrix has 3 zeros in the first row, the second row, the third row is called 0 matrix of order 3 times 3 square matrix. 0 matrix is denoted by this symbol. Also the matrix 1 0 0 1 is called unit matrix of order 2 times 2. It's called I2. Why? Because the principal diagonal must be equals all elements 1, all elements except principal diagonal are equal 0. This matrix is a square matrix. It's called unit matrix. Its order 2 times 2. Diagonals, elements of the principal diagonal 1 1, and all elements except matrix elements of diagonal or principal diagonal equals 0. The matrix 1 0 0 0 1 0 0 0 1 also unit matrix of its order 3 times 3 is called I3. I2 has square matrix, but I3 means unit matrix, has 3 row and 3 column, but the principal diagonal, all elements must be equal to 1 and all elements are zeros. One is called multiplicative identity element. I is called multiplicative identity element. This is commutative property. When multiply any matrix times I equals I times A equals A. Unit matrix multiply any matrix equals the same matrix. A times I equals I times A equals A. Now we are translate to another title. It's called transposition of matrices. If a matrix, its first A, B, C, first row, second X, Y, Z, its order 2, 3, and we put A transpose as replace the first row by first column, the second row by the second column. A transpose becomes AX, BY, CZ. What you do? We replace all elements of the first row in the first column, the second row, the second column. This is called AT or A transpose. AT is called transpose of the matrix A, and we deduce that AT for all power T equals A. What you mean? Transpose of matrix equals the same matrix. This rule, AT for all power T equals A. Addition of matrices. We can add two matrices if they have same order. Look at matrix A 2, -3, 4, 1, 5, 7. This matrix has 2 row and 3 column. Another matrix B 3, 1, 5, first row, -1, 2, -4, second row. Look at the two matrices have the same order. We can add or subtract. The first condition when add two matrices must be in the same order. The first matrix is order 2, 3. The second matrix also its order 2, 3. 2 rows, 3 columns. 2 rows, 3 columns. When we add A plus B, we add 2, -3, 4, 1, 5, 7 plus 3, 1, 5, -1, 2, -4. Add each element with corresponding it. 2 plus 3, 5, 2 plus 3, -3 plus 1, 4 plus 5, 1 plus -1, 5 plus 2, 7 plus -4. Then the answer is 5, -2, 9, 0, 7, 3. This resultant of A plus B. Note that the addition operation is commutative when add two matrices. What you mean? A plus B equals B plus A. And transpose of addition two matrices equals sum of two transpose of two matrices. A plus B for all T equal AT plus BT. AT means transpose of A. BT transpose of B. Multiplication of matrices. If we have A is a matrix of order m times n, and another matrix B, its order x times y, then what is the condition when find A times B? We have two matrices A, B. A matrix, its order mn. Matrix B also its order xy. A times B satisfies if n equal x. What do you mean? N, the number of columns of the first, equal x, the number of rows of the second. This is the condition when multiply two matrices n equal x. When n equal x and the matrices AB is its order must be as m times y. Look at this example to clear that multiply of two matrices. The first matrix A 1 2 3 negative 1 negative 3 5. B matrix is negative 2 6 4 negative 4 negative 5 1. Dear student, look at the matrix A. What is the order? Excellent student. 2 3. 2 row, 3 columns. Look at the matrix B. What is the order? Excellent student. 3 2. What you know? We know that the number of column of the first equals the number of rows in the second. This is the condition when multiply A matrix times B matrix. We can find A times B. Yes. Why? Because the number of column in the first 3, the number of the row in the second 3 must be equals, then we can find A times B. A times B equals 1 2 3 negative 1 negative 3 5 times negative 2 6 4 negative 4 negative 5 1. Look at when multiply A times B, we use the first row multiply the corresponding element in the first column. 1 times negative 2, 2 times 4, 3 times negative 5. When we find A 1 1, first row, first column. Look at 1 times negative 2, 2 times 4, 3 times negative 5. The second, 1 times 6, 2 times negative 4, 3 times 1. The second row by the first column, negative 2 times negative 2, negative 3 times 4 plus 5 times negative 5. Second row times the second column is negative 1 times 6, negative 3 times negative 4, 5 times 1, and calculate the answer. Then A times B is negative 13 1 negative 35, 11. This is product of two matrices A and B. Note that, dear student, A times B equals B times A. A plus B transpose equals B transpose plus A transpose. Multiplicative inverse. Also, A times B transpose equal BT, AT. The multiplicative inverse of a squared matrix in order 2 times 2. We studied before that, if A we have A matrix, A, B, C, D. Is square matrix, its order 2 times 2. Then its multiplicative inverse is symbol A power negative 1, 1 over determinant of A, multiply, we change the element on the principal diagonal, replace the element AD, DA, and change the sign of the second element of the second diagonal. Look at the student. Inverse of matrix is 1 over determinant of A multiply matrix, but this matrix we replace the element of the first diagonal or principal diagonal and change the sign of element of the second diagonal. This is formula of inverse matrix, has 2 row and 2 column, where determinant A equals A, B, C, D cross A, D not equals 0. Why? Because if the determinant of matrix equals 0, then has no multiplicative inverse. This is the condition when we find inverse of matrix. At the first, calculate the determinant of this matrix. If the determinant equals 0, then the matrix has no multiplicative inverse. And we know that if determinant equals 0, then matrix has no multiplicative inverse, and the matrix is called singular matrix. What you mean singular matrix? This matrix, its determinant equals 0. Remember this student, if determinant of any matrix equals 0, then the matrix has no multiplicative inverse. But if the matrix determinant of matrix equals 0, this matrix is called singular matrix. Remark, dear student, A times its inverse equal inverse times its A equals I. Identity matrix. Find inverse of A if A matrix equals 1, negative 2, 3, negative 4. Solution. As a first, calculate determinant. What is the determinant of matrix? Equals 1 times negative 4 equals negative 4 minus negative 2 times 3, negative 6, negative negative equals 6 equals 2. Determinant not equal 0. Then the matrix has inverse. It's a condition of inverse. Then what is the inverse? 1 over determinant, 1 over the 2, and the change or replace. Look at, we replace the element of the first diagonal or principal diagonal. Replace the element 1 negative 4, replace negative 4 1, and you change the sign of the second diagonal. Negative 2 becomes 2, 3 becomes negative 3, and multiply each element by 1 over 2 equals what? Negative 2, 1, negative 3 over 2, 1 over 2. This is inverse of matrix, but in square matrix. Another example. Prove that there is no multiplicative inverse of matrix A 2, 4, 3, 6. What is the condition, dear student, if we prove that this matrix has no multiplicative inverse? Excellent student, determinant equals 0. If you find determinant of this matrix by product the principal diagonal element of the first diagonal minus multiply of element of the second diagonal must be equal 0. Solution. Determinant A 2, 4, 3, 6 equal 12 minus 12 equal 0. Then the matrix has no multiplicative inverse. Why? Because determinant equals 0. This is called singular matrix. This matrix is called a singular matrix. Why? Because determinant equal 0. Another example. Find the value of k that makes the matrix A 9, 4, A has multiplicative inverse. Find the value of A when matrix A 9, 4, A has multiplicative inverse. Determinant equals 0. Then A 9, 4, A determinant equals 0 by using A times A square minus 4 times 9 equals 36 equals A, then A square equals 36, then A equal positive or negative 6. Dear student, when the matrix has no multiplicative inverse, to find the value of A, we find the determinant of the matrix equals 0. This matrix is a square matrix. Square matrix has 2 rows and 2 columns. We multiply all elements on the first, A times A square, minus all elements in the second, 4 times 9 equal 36. Then A square minus 36 equals 0. Therefore, A square equals 36. Then A equal positive or negative 6. The multiplicative inverse of matrix of order 3 times 3 is very important title. Multiplicative inverse of matrix of order 3 times 3. Look at, dear student, multiplicative inverse of matrix of order 3 times 3 has 3 rows and 3 columns. Remark, the matrix A has multiplicative inverse if determinant not equal to 0. Number 2, if A is a square matrix and inverse of matrix A negative 1 is its multiplicative inverse, then if multiply A times its multiplicative inverse equal multiplicative inverse or inverse of the matrix times A equals I. where I is unit matrix. Example. Determine whether the matrix A 3, -1, 2, -1, 2, 1, 1, 0, -1 has multiplicative inverse or not. Dear student, we have matrix has 3 rows and 3 columns. What is that required? Show that or determine whether the matrix has multiplicative inverse or not. Remember, dear student, the matrix has no multiplicative inverse if the determinant equals 0. Then we calculate the determinant of A by first row, second row, third row, or any method to calculate the determinant of the matrix A. If the determinant equals 0, then the matrix has no multiplicative inverse. If determinant not equal 0, then we say that the matrix has multiplicative inverse. Solution. Look at determinant A. We put all elements of matrix inside the determinant by using 3 times the square determinant, 2, 1, 0, -1, -1, multiply its determinant. Remember, when we find this method is called the first row method, to multiply its determinant -1, 2, 1, 0. Remember, dear student, each term, each element in the first row has determinant. 3, its determinant 2, 1, 0, -1. -1 has determinant -1, 1, 1, -1. 2 has determinant -1, 2, 1, 0. What is the determinant of element 3? We cancel the first row and the first column. Why? Because 3, A, 1, 1. Its position 1, 1. First row, first column. We removing the first row and the first column, then the remainder determinant is 2, 1, 0, -1. -1 is A, 1, 2. 1, 2 means the first row, the second column. We remove the first row and the second column. The determinant is -1, 1, 1, -1. Also 2, its position A1, 3. A1, 3 means the first row, second column. We remove the first row and the third column. The determinant of 2 is -1, 2, 1, 0. By using 3 times bracket contains -2 minus 0 plus 1 minus 1 plus 2 times bracket contains 0 minus 2. Answer is -10. Determinant value is 10, -10. Means has multiplicative inverse, not equal 0. Then the matrix A has multiplicative inverse. We say that the matrix A has multiplicative inverse and is called non-singular matrix. Dear student, I am very happy to spend such time with you. Remember, math simple, think, work, produce. Goodbye.